How does this explain their chemistry? It means that in every chemical reaction, you find group 2 elements, right? They would ionize. They ionize by loss of 2 electrons, which would be their 2 valence electrons now. They ionize by loss of 2 electrons to form a dipositively charged ion. To form a dipositively charged ion. What does this mean? You will agree with me that every element wants to mimic the noble gases in terms of atomic stability. This has been explained in our lecture on chemical bonding, that every element or every atom wants to mimic an atom of the noble gas. Now, if magnesium here is to obey a stable octet, what must happen? One of two things can happen. It's either magnesium gains 6 more electrons in addition to these 2 to make 8, or magnesium loses these 2 outermost electrons, so the next shell, which is beneath, can have 8 electrons. Now, it is only reasonable that magnesium loses its 2 electrons because no atom is willing to donate 6 electrons to magnesium. It's not possible. You need 8, and then one atom comes to give you 6. That's not possible. But then you have 2. You can donate those 2, so you can have 8. And then that's how group 2 elements ionize. They lose the 2 valence electrons they have to form a dipositively charged ion. So when we take the chemistry of that, what do we have? Means that beryllium, right, solid, will lose 2 electrons to form a dipositively charged ion. And of course, you know that ion will be dissolved in its solution, aqueous. And then here, if you rearrange that, you have this to be beryllium 2 plus aqueous plus 2E minus. All right, so this is an ionization of the group 2 element of beryllium. It has lost 2 of its valence, all of its 2 valence electrons to form a dipositively charged ion. So if I ask you to give me the ionic equation for magnesium, what would you say? Also being a group 2 element, will form a dipositively charged ion upon loss of its 2 valence electrons. And that's it. And then this holds for all group 2 elements, all of them. All right, what other characteristics of group 2 do we have? What about their reducing ability? What can we say about their reducing ability? Now, we've established the fact that group 2 elements also donate electrons, now 2 electrons. And then you know loss of electrons defines oxidation. And then when you have a chemistry, any species that is oxidized, right, is the reducing species, because what has happened? Itself being oxidized has caused the reduction of another species. Hence, it's an agent of reduction with respect to that species in that equation, right? So it means that group 2 elements losing the 2 electrons, the 2 valence electrons, means that they are oxidized in chemical reactions, hence are reducing agents. But now let me ask you, if you have 2 elements A and B, atom of element A has 1 valence electron, and atom of element B has 2 valence electrons. Now to element A, which of them do you expect to lose electrons most readily? The atom with 1 electron, or that with 2 electrons? Of course, the one with 1 electron, because it is easier to lose 1 electron than losing 2. You can picture it as gold. You have 1 bar of gold, and someone else has 2 bars of gold of the same carat. Now, you don't expect losing 2 bars of gold to be easier than losing 1. Of course, losing 1 is easier than losing 2. Of course, you have 1 more left, right? So what that means is group 1 elements are more readily ionized in solutions than group 2. Hence, group 1 elements comparatively are better reducing agents. Hence, group 2 elements are less as good as group 1 when it comes to reducing ability. So what can we say? We say that group 2 elements are good reducing agents or are better reducing agents. They are better reducing agents than group 3, and you understand why that is. Than group 3. Permit me to write that in shorthand. But less as good. But less as good as group 1. So you understand this now. They're better reducing agents as group 3 because they can easily lose 2 electrons compared to group 3, which wants to lose 3. But they are less as good as group 1, right? And that's it. Now, what can we say about their triazocarbonate 5 salts? Triazocarbonate 4 salts, sorry. What can we say about the triazocarbonate 4 salts? Now, you remember what we said for group 1, that the triazocarbonate 4 salts are thermoresistant, which means if you heat them up, all right, to temperatures below 800 degrees Celsius, you do not expect anything reasonable to happen, right? And then many of them to far more than 1,000, even 2,000 degrees Celsius before they decompose. So as a result of that, we said they were thermoresistant. But that is not the case for group 2. Group 2 elements are not thermoresistant. In fact, they are thermolabile, which means that upon application of heat, their atoms decompose, right, to give you their constituent compounds. So let's see what compounds are produced upon the thermal decomposition of alkali earth metals, the carbonates of alkali earth metals. Via triazocarbonate 4 salts. Triazocarbonate 4 salts. Carbonate. Right? Are thermolabile, we said that. Thermolabile. Okay? They decompose. They decompose in the presence of heat to give the oxide of the metal as the oxide of the alkali earth metal now, to give the oxide of the metal. If you understand periodic table very well, you would find your non-metals and their compounds, and even metals and their compounds, very easy to understand, right? So if you understand the tricks or the rules guiding every reaction, you'll find chemical reactions in general very easy, and then your non-metals and their compounds also very easy. So they decompose to give oxide of the metals and liberate carbon 4 oxide gas. And liberate carbon 4 oxide gas. We'll look at a couple of reactions now. And then they liberate CO2 gas. And that's one of the ways you can produce carbon 4 oxide in the laboratory. One way to produce CO2 is decomposition of the carbonates of group 2, right? It gives you CO2. If you're asked in your exam to describe one laboratory preparation of carbon 4 oxide, you can give them this. The decomposition of the carbonate of a group 2 element. So what group 2 elements do we have? Magnesium, right? Let's start with magnesium. Magnesium carbonate, right? MgCO3 can be decomposed in the presence of heat. The small triangle on the arrow signifies heat in its solid state to give us magnesium oxide, which is the oxide of the metal. What else do you have? You have carbon 4 oxide gas liberated. Very simple chemistry. They are thermolabile and decompose upon heating to give the oxide of the metal and the liberate carbon 4 oxide gas. And then you can predict what product you have here. Since calcium is also an alkali earth metal, it decomposes upon heating. To give the oxide of the metal, which is calcium oxide, and liberates carbon 4 oxide gas. Sweet dear.